In this problem, we're told that for bone density scores that are normally distributed with a mean of 0 and a standard deviation of 1, so immediately I know we're talking about our standard normal distribution. We want to find the percentage of scores that are, in part A, significantly high, or at least 2 standard deviations above the mean. So I've got my normal distribution here. I label the horizontal axis 0, 1, 2, 3, -1, -2, -3, and we want 2 or greater. Now, we don't have to worry about whether we're actually including the 2 or not. With a continuous distribution, it's going to be the same probability if we have 2 or greater or greater than 2. So it makes a difference when we're working with the binomial distribution, which is a discrete distribution, but in a continuous distribution, you calculate it the same way. So how am I going to put this in the calculator? I'm going to do normal CDF, and then I put in my left-hand boundary. So on the left, that would be 2. On the right, we're going to infinity, so that's 1e99. And we can type this in by pressing 1, and then second, and the comma. So if you look above the comma, it says EE. So there's 2 E's. We don't want the single E key. We want the double E key, even though it only has 1 E when you type it in, which is weird, but that's the way they did it. And then after you do that second comma to get the E, then you type the 99. And then comma 0, comma 1. And when you hit enter, you get 0.0228, and that's my answer for that problem, or 2.28%. So that's my answer for that. Now let's try the next one. It says the percentage of bone density scores that are significantly low. So now we want the percentage that are significantly low, which is going to be at or below -2 on the horizontal axis. So I'm just going in the opposite direction. Notice that this distribution is symmetric, right? The right-hand side is a mirror image of the left-hand side. So I'm actually going to get the same answer for this one. But if I were to type it in, I would be typing in normal CDF. Open. I'm going from -infinity to -2, and then 0. Oops, that's a 0, not a 6, and 1. And this is going to give me, again, 0.02, oops, 28, or 2.28%. And that's the answer for that one. Okay, so then finally, what percentage of scores are not significant that are less than 2 standard deviations away from the mean? So now I want to go from -2 to +2. So notice this is going to be a large percentage. The nice thing about sketching the distribution is that you get an idea, is this going to be a large probability or a small probability before you get started. So I'm going to put in normal CDF, and I go from -2 to 2, and then my mean is 0 and my standard deviation is 1. And when I put that in, I get 0.9545. Remember, the empirical rule said that roughly 95% of scores fall between -2 and +2 standard deviations. So That's where that actually comes from. So it's the same 95%. It's a scooch off, they just don't go out that many decimal places. So that is how you do those problems.